Hello and welcome to another episode of the EnVisioneering Exchange, the podcast where industry leaders discuss the most important topics in HVACR. I'm your host, John Sheff, Danfoss's Director of Public and Industry Affairs. Now, you can subscribe to our show on Apple Podcasts, Spotify, SoundCloud, or wherever it is you get your podcasts. Today, we're going to be talking about hydronics and hydronic HVAC systems, a topic that's really not very well understood. And I'm thrilled to be joined by my guest, Jae Chon, Director of Strategic Markets at Chesapeake Systems. Now, Jae and I have worked together in the past. We'll get into a little bit of that in a minute. But Jae, why don't you introduce yourself?
Sure. Thanks for the introduction. Again, my name is Jae Chon. I'm with Chesapeake Systems, and I am the Director of Strategic Markets. And to tell you a little bit about myself, I've been in the commercial HVAC industry for 30 plus years. I've worked in the field during the early years, starting off in building automation systems. I saw the transition from pneumatic controls to analog electronics, and eventually where we are today with DDC controls. At that point, I took an interest in the mechanical side of things and decided to go back to school for a mechanical engineering degree. From there, I went to work for a consulting firm as a design engineer with primarily mechanical systems, working on designs for commercial office spaces, laboratories, some specialized industrial process facilities, as well as clean rooms and labs. Later, moving into sales, I worked for a rep firm that specialized in hydronic products and did that for most of my last 15 to 20 years, specializing in hydronic systems, and that's where I am today. So, I work for Chesapeake Systems. My role is to work directly with owners, focusing on what we're calling our strategic markets, government, schools, hospitals, institutional accounts, and also large property management.
Now, full disclosure, Jae actually worked for Danfoss not too long ago before he was at Chesapeake. So we have some familiarity with him there. But Jae, why don't you give us a little idea what Chesapeake Systems actually does?
So Chesapeake Systems is a regional manufacturer's rep. Most of our products are in hydronics focus. So, cooling towers, pumping systems, heat transfer products, as well as power electronics for variable speed drive. And our mission and our focus is primarily to offer owners the ability to save energy with all the products that we have to offer.
And I think one cool thing about Chesapeake is that they have a guy like Jae, where Jae is actually going out and engaging end users before these projects are conceived, understanding what their problems are. And like he said, he's one of the few people I know that really understands hydronics and understands how systems all work together. And so Jae and I worked on a project about a year ago that we were calling the Synchronized hydronic loop. I know that can sound a little jargony, but we were really trying to get the idea that in these hydronic systems, you need to sync up all of the components that make up the system, the chiller, the boiler, the pumps, the air handlers, and the valves. Why is that important, Jae? And why is it kind of not well understood?
That's a great comment to start off. It's important because we cannot look at a system based on individual components, which is pretty much what they do today. We look at the major components of a system, let's say a chiller, pumps, boilers. But what we don't look at is the smaller components that add a lot of value only because you don't see them. However, there's a symbiotic relationship and function and purpose of each component, whether it's something small or whether it's something significant to the system. So let's look at some of the things that I've seen is that, let's say, for instance, they take a non-condensing boiler and replace it with a condensing boiler without considering the impacts of the entire system. We see that all the time. We see that it impacts the balancing of the system due to pressure drop changes, in addition to trying to maintain return temperatures to keep them above condensing conditions. So what we find is that the misapplication with the right intents of trying to save energy causes equipment failures within a period of 5 years or less.
You and I, even in my limited experience doing this, have seen a lot of misdiagnosed problems, things that, building operators may think is a pump problem, a chiller problem, but really it's a system problem. And you call them, and I kind of picked up on this, a sick building. I mean, it kind of explained the concept of balancing, how an out of balance building can be, quote, sick.
Sure. From a balancing perspective, let's take a hydronic system. Let's consider the fact that they add a variable speed drive to a constant speed pumping application. It makes sense to put variable speed drives on pumps because we can capture a lot of energy savings. However, in a constant speed system, they may have three-way valves and is balanced with manual balancing valves. And, this type of balancing works great in a constant volume system. The pumps run at full speed, and there's always plenty of upstream pressure for the valves to have enough CV to control the flow into the coils. However, when we add a VFD for this type of system, we vary the speed of the pumps, and we are now controlling to a wide range of upstream pressures. This can have a lot of impact to, the flow to the coils. And when we don't have proper flow to the coils, we tend not to get the, right amount of heat transfer. And that tends to lead to poor temperature controls in the space. That also could lead to humidity issues, which then lead to mold issues. It would lead to an unhealthy building, let's just say, or sick building.
This lack of balancing not just can lead to many things. Hunting, we call, where water temperature swings through the system, even though conditions really aren't changing. And so it can manifest itself in comfort issues, but like you said, also in real health issues where whole parts of buildings need to be shut down because they're so humid, or mold issues. This is really kind of a systemic thing that can manifest in a lot of different ways and cause a lot of problems for commercially occupied spaces.
Correct. It's mostly manifested in comfort. Then it can lead to a sick building. And it often leads to shortened, life cycles for, the main components and, equipment. Let's say, for instance, if we overflow a system, we could have low delta T conditions, and that could certainly cause chillers to, short cycle because of the low delta T, and that can lead to shortened life.
And yeah, so Chesapeake carries a Danfoss product called our ABQM pressure independent control valve. And this is kind of an alternative to the traditional manual control valves that you usually see. And it's a technology that is, very well accepted in Europe, but really just starting to make its way over here and can really solve a lot of these issues, right?
Yeah, absolutely. Going back to the conditions of varying upstream pressures when we add variable speed drives to pumps, the solution with an ABQM valve is the fact that it is unlike a manual balancing valve, which is a fixed position valve, it's a dynamic valve. So what it can do is it can actually adjust to the upstream pressure changes, trying to regulate a constant pressure drop across a known orifice to a setting that we can actually set. So if we decrease in the upstream pressure, the valve notices a pressure drop change across that orifice, and then there's a diaphragm that will react to open the valve more to let the proper amount of flow through. So it's a great product in solving, a problem that we see all the time with the energy mandates by adding VFDs. So, we're not applying our best practices by using manual balancing valves. The ABQM would be a great solution to giving us the proper flow rates, which would give us the proper temperature controls and heat transfer that's needed in the coils to be able to control the temperature in the space.
Yeah, and it's crazy some of the things that you see. I've seen some very expensive buildings with some very expensive brand new HVAC systems, variable speed chillers, variable speed pumps, but where the pumps are running and the chillers running flat out all the time and spending a lot of money, wasting a lot of energy and kind of, not utilizing the technology correctly because they have, these fancy pieces of equipment, but the system is not balanced and they're using manual balancing valves.
Right, that's correct. That goes back to what I said earlier about applying right principles, however, not looking at the whole entire systems approach to what we do, especially in hydronics.
And yeah, so when Jay and I worked together on our Synchronized hydronic loop project, we were really trying to pitch this idea to building owners of looking at the system as a whole and looking at components on many different levels and how they impact each other. And we did have some success, but Jay, as a business development executive, when you're talking to end users, when you're talking to building operators and you're introducing this idea, how do you talk to them about it?
Well, with owners, what we've seen over the years is that they've started to, I guess, water down the facility engineers, and part of that may be because of lack of training in the industry. And then they started to rely more on contractors. And what that has left is a lot of issues with their building because they don't have anyone in-house to keep up with everything on a day-to-day basis. They wait till things fail, or they wait till things manifest as a problem. And so when we have problems like that, that becomes an opportunity for us to go in and talk to them about their system and not, let's just say, a boiler or a chiller when that manifests as a problem. So, we're trying to look at it from more of a holistic picture of systems as opposed to looking at things from a componential outlook.
But a lot of these guys, particularly these mechanical engineers, and they may be consultants, they may be facilities operators, but they've been doing this for a long time and they think they know their way around a building, but they have these issues. Is it difficult to convince engineers that changing a valve and an air handler can significantly impact the chiller performance, the pump performance, the system performance?
It is. Sometimes, you get the aha moment right out of the gate when you start to explain the problems all the way from the two types of heat transfer that occurs, and that's the air side and then the hydronic side of the system. And then when you explain that they're not getting the proper flow, and that's why they're not getting the proper heat transfer, and that's why that space or that part of the building has become a dead zone, let's just say. Sometimes they get it, sometimes they don't. It's a huge undertaking. It's an industry change because the way we approach, or most engineers and even contractors approach things is, well, this is the way I've done things for years and it's worked. However, it really doesn't work. And, you really can't see up in the ceiling to see, what the flows are happening or what's happening at the VAV boxes, fan coil units, or air handling unit coils. What we tend to see is when we are uncomfortable or we have issues within the building. And sometimes by then it's too late. So we try to get them to visualize what's happening behind the scenes, which is not so visible. Today, part of the problem is actually that, there's so many buildings that are now controls heavy. So we've layered PID over top of PID to try to fix these problems. Well, it does help in some cases in the comfort level. However, we don't see what's happening behind the scenes in the water side of it, and we lose efficiency. We have a tendency to have low delta T to the chillers. And those are the things that are not as visible and obvious. So that's the part of it that we have to start educating people. And it's a huge undertaking to get there.
Yeah, and I think, when we were working together, one of the things that we kind of ran into was, just like you said, the controls industry. And some of these, controls companies were pitching their software solutions, but it's really not a software solution. It's a mechanical solution that will make the software operate much more efficiently and be able to control the building a lot more efficiency. But it's just funny that some of these controls companies are not seeing the light and how their products can really work much better if the building is balanced mechanically.
That's correct. I would agree with you 100% there.
Yeah. So you talked a little bit about this, but kind of what are the barriers to implementing this approach from a technical standpoint? Is it as easy as just changing the valves out? I mean, what needs to happen?
It can be. Let's say, for instance, we're looking at a system that we recognize has a problem that's been designed already, that's already been installed. The challenge there becomes in access to some of these valves, in addition to the owner not wanting to make piping changes, which can be very costly after the effect. So, again, the part of us working with owners to make sure that they understand what they're getting when they put together a comprehensive solution, which is our approach at this point, that they'll get exactly what they're asking for. I mean, part of it is that, when you look at the project life cycle, an owner may have a vision of what he's looking for. However, we deal with consulting firms or engineers that go in and they hear the owner and they may base it off of their interpretation of what the owner is looking for. And they use their best practices, and that may be balancing valves to them because they don't understand the dynamic conditions of balancing. And then the drawings or plans come out and it goes out to bid. Then the contractor interprets that engineer's design and then may move forward with their interpretation. Then it goes to vendors who, put together bid packages for contractors to go in and bid. And it's based on their interpretation as well. So there's so many interpretations of, what the owner may have originally wanted. And by the time it goes through that pinball machine of bid, the owner may not even get what he's asked for or the performance that he was expecting to see. And so that's where we're trying to stay ahead of that, get involved early on, educate the owners whenever we can so that we can kind of stave off those long-term problems that exist.
Yeah. So, I mean, this is one of the issues that Jay and I identified early on. And I think Jay knew it well before I did. And this is what makes Chesapeake so special is that they really are going out there and trying to identify these buildings, identify these projects before maybe even the end user really even knows about them. And, as opposed to a lot of rep firms who are sitting back at the end of that supply chain that Jay just described and taking the order from their vendors, Chesapeake is really out there developing these projects. And that's why Jay is able to help so many building owners, identify these sick buildings and really solve the problem instead of just being part of the supply chain. And because once it gets sent out to bid, it's kind of over because, like Jay said, these contractors, a lot of them will just do what's comfortable. And this is not necessarily comfortable, but it is a technology that can solve a lot of these problems. So, it's a technical issue and it's a market issue too. And some of that supply chain needs to be broken a little bit to kind of get at these difficult projects. And so, Jay, how do you see this? I know you've described it's a little bit tough to break that supply chain, but how do you see this market evolving right now? Do you see more acceptance of this? I mean, do you think it's going to get easier? Or you're still kind of fighting the tide here to get this concept kind of widely accepted?
It's tough. When we focus more on a regional market, it's harder to get more of a national standard to create a better system utilizing the best practices here. I mean, all we can do is work in our local markets, but it really does have to be something that reaches far beyond that. And I think that could be where Danfoss comes in to help out, because you guys are an industry leader in this type of environment, and you guys could probably influence on a much wider level to help us get these standards set in place.
Yeah, well, we're trying, and we're actually taking the pilot project that you and I worked on and moving it into other regions. So, the team is out there working to kind of introduce this technology. But yeah, right now it is kind of region by region, unfortunately. Now, in the DC market, we've seen a lot of momentum towards some of these building emissions laws. And I know DC has a relatively strict one coming up with some financial penalties for non-compliance. I mean, do you see that kind of moving the needle as building owners really look to get under these emissions caps and save energy and really taking a hard look at their buildings?
They are. I think part of the issues that I'm seeing is that ESCOs get involved, and depending on the level of understanding of an entire system, it could vary. I mean, there's been times when I've gone into projects where ESCOs have guaranteed performance and energy savings, and they really don't understand hydronics. So that part of it is somewhat lacking. And, we start to see the problems that we had discussed earlier. Boilers, short cycling, chillers, short cycling. They don't understand the piping systems, primary, secondary, even tertiary systems. And a lot of that has to come into play in laying out best practices for a hydronic system, depending on what equipment that you're going to be putting in and how you utilize it.
Yeah, and just so for those who don't know, the ESCO that Jay referred to, energy services companies, these are kind of some of the controls companies or the performance contractors that you might see out there doing some of this work. And you see a lot of these, chiller plant optimizations and stuff like that, but they don't necessarily address the balancing of the building, the terminal points, the air handlers, and where that water is actually flowing, the heat exchange and all that heat transfer and all that. So not a lot of people out there with a comprehensive view of how these systems work. So I think more of that is definitely needed in the market. Jay, do you see, I know you're doing it, but do you see a lot of other experts out there who really have this understanding?
There are a few, but, it's not an industry trend, or it's not being utilized by most.
Yeah, that's a shame. And definitely so that Danfoss is looking to change. Well, Jay, I think that's going to do it for this episode of the EnVisioneering Exchange. I'd like to thank, again, Jae Chon, Director of Strategic Markets at Chesapeake Systems. And don't forget to subscribe to the EnVisioneering Exchange podcast on Apple Podcasts, Spotify, SoundCloud, or wherever it is you listen to your podcast. Lastly, if you really enjoyed this episode, don't forget to rate, review, and share it with your friends. It really helps us out. Thanks for listening. I'm John Sheff, Director of Public and Industry Affairs at Danfoss, and I'll talk to you next time.